Hello, my name is Xander. Welcome to part 5 of the Python Beginners Plus course. Now, this course is a course which puts into practice what we learned from the Python Beginners course. There's a link in the description for that initial course if you are new to Python. The idea here is that in the Beginners Plus course, we're trying to introduce different Python pathway developments. And here we're looking at sorting algorithms. So in the previous tutorial, we took a look at the bubble sort algorithm from a practical standpoint. And now we're just moving over to the insertion sort algorithm in this tutorial. So ideally, because we're going to work from the previous tutorial, the code, you would have an understanding of Python list, if statements, for loops, and hopefully have seen the first tutorial in this kind of mini series within the Python Beginners Plus course, the bubble sort tutorial. So let's just get straight into this. We're going to have a quickly recap the bubble sort algorithm, how the mechanics worked of this algorithm from the previous tutorial. So bubble sort. So the idea here, we had a set of numbers or a list of numbers 4, 3, 2, and 1. We wanted to sort them out. So we wanted to sort them out from lowest to highest. So 1, 2, 3, 4. So this was just a set of numbers that we were provided. So how the bubble sort algorithm mechanics work is that we would first of all take the number in position 0 in our iterable here. This is our list. And then we would compare it against the adjacent number. So in this case, number 3. So we would run an if statement, say, so is 4 greater than 3? If it is, it means that these numbers would be exchanged. So 3 would be moved into position 0 and 4 would move into position 1. And then our algorithm moves on to a next step. So we look from position 1 to position 2. The same thing again, is 4 greater than 2? Yes, we'd swap them over. And then we do the same thing again. We look at position 2, swap them across. And that is then the first iteration of bubble sort. And then how bubble sort will work from there is we'll just iterate around again. This time starting from 0 again, moving across. You can now see that we end up with 2, 1, 3, 4. And then the last iteration, or towards the final end of this algorithm, we would eventually get to the point where all these numbers are then nicely sorted, lowest to highest, 1, 2, 3, 4. So in the previous tutorial, we also then moved across to start to look at performance in a practical way, and we measured the performance of this algorithm. I gave you a method of measuring the performance of this algorithm, how long it might take to perform this sorting given a larger set of numbers. So now let's move across to insertion sort. We'll do the same thing here. We're just from a practical point of view. Remember, this is just really kind of initial introduction. We're not going into too much depth with, for example, performance here, like we had in the first tutorial. So from a practical standpoint, then this is how the insertion algorithm is going to work. So we're given the same set of numbers as we performed on or using the bubble sort algorithm 4, 3, 2, 1. We want to order these, so we end up with 1, 2, 3, and 4. So these can be any numbers at all. This is just an example. So insertion sort. So we start off then by taking the number in position 1 of our list here, and we're going to store that in this variable here called p. And then what we're going to do, our algorithm is going to be designed so it takes the number in, this is the first iteration, it takes the number in position 0, and then we compare it against what's saved in our variable here, p, which is obviously 3. So is 4 greater than 3? So if 4 is greater than 3, it means that we need to move this 3 where the 4 is and swap them over. So what happens is that 4 would get copied over to position 1. So that's the first step. And then what we do is we use the number that's stored here in our variable p, which was 3. That was the initial number here in position 1. And then we place it at position 0. So that takes us through the first iteration of this insertion sort. So now we move on to the next stage. So similar to bubble sort, we now move over to the next step. So where we were first of all looking at position 1, we're now looking at position 2 here in our list. So the number in position 2, we're going to take that and put that into memory here, into our variable. And now we're going to compare that against the adjacent number, so number 4. So is 4 greater than 2? If it is, it means that 4 is going to be copied over to here, position 2. So this happens. And now what happens is we now skip down to the next number. So we've compared our initial number to the adjacent, and now we're going to move down to the next number. So this is in position 0, number 3. So what we're now going to do is the same step. We're going to we're going to check to see if this number is greater than the number that we're storing, the original number 2. Now, if it is, what will happen, similar to the 4, that 3 is now going to be moved across to the next position. So eventually, this inner iteration is going to get down to 0, for example. So when it gets down to the last step here, what's going to happen is that inner loop will break, and then the number here that's stored in our p variable here is going to be placed in position 0. So that gets placed into that position 0, and then that's the end of that iteration. So that's our second iteration of this number set here, this list. So now what we need to do is, you can now see we're going to need to move to the last position here. So we iterate now over this list again, but we start from this position here. So notice how we're slowly kind of moving across here each time we iterate over this list. So here we're going to move position 3, the number here in position 3 in our list. We're going to store that into our memory, and you can kind of see what's going to happen now. So we're going to compare that against 4, and then we're going to copy that across because 4 is bigger than 1 or greater than 1. We'll do the same thing with 3. Is 3 greater than 1? Yes. So we copy that across there, and then we do the same thing in position 0 here, and then that moves across. So now that leads us to a point where we now break that inner loop, and we now put the number that's stored here in our p variable into position 0. So let's now go ahead and build this algorithm programmatically. So now we know how this is going to work. So let's go ahead and do that. So first of all, we're going to need some numbers to sort. So NTS, numbers to sort. And then I'm going to create this nice little list here, 4, 3, 2, 1, similar to what we had in the example. Right, so we're going to use a function here. I'm going to call this Insertion Sort. And we're going to need to pass into this function our numbers. So here we have a parameter NTS, so that's going to allow us to pass numbers into this function so that we can then sort them. So next up then, we're going to need an outer loop. Now remember how this algorithm works. Similar to the bubble sort, we're going to need to iterate over this number set a certain amount of times. So for example here, we know that we're going to start from this number here, and we're going to need to iterate over this set of numbers enough time so that we can sort all these numbers. So let's go ahead and now set a range. So we're going to start from 1, because you remember when we iterate over this list to begin with, we want to start from position 1, not position 0, because we want to take this number and put this number into memory. Let's just go back to start. So we take this number here, we put that into memory, and then we compare it against position 0. Okay, so we start from 1, and then we get the length of the list here, which is going to be 4. So here we have a range of 1 to 4. So now we have a range here from 1 to 4. So 1, 2, 3, and 4. So that's how many times we're going to iterate over this list here. So what's going to happen, this is going to loop through. It's going to be number 1, I is going to be number 1. We loop through again, I is going to be number 2. We loop through again, I is going to represent number 3, and so on. So these are positions that we use to grab items or grab numbers from our list here. So what we're going to do in the first iteration, we're going to get our list that's being passed into our function here. And we're going to get I. So I is going to represent 1. So what we're doing here is we're selecting the number in position 1 from our list, which is number 3. So the current number is going to represent, or in current number variable is going to store number 3. So that's the first step here, and that just matches what we've done here. So now we have number 3 in our variable. Here I've called it P. In the example here, we've got current number. So now what I need to do is I need to compare it to position 0. So let's go ahead first of all and we need to get position 0. So what we do here is we say P for position, say, we need to get what's stored in I. So in the first iteration, I is storing number 1. We need to take away 1 because that's 1 less in our list that we want to have a look at. So we want to look at this number here. So we take away 1, that produces 0. So P now is storing 0. So now we have that 0, what we can now do is generate our kind of inner loop here. So while P is more than or equal to 0, okay, so at the moment P equals 0. So that is true, so we're going to move on. Now what this is for here is every time we iterate over this, as we get further into this list, say here, position 3, what's going to happen is we're going to keep looping over this list until we get to 0, and then minus 0 is going to be minus 1, and then this will be false. So at that point, we don't need to loop round again. We know that we've looped around all the numbers in this list, and now we can then go to the outer loop and now loop around again. So P is greater than or equal to 0. So while that is true, we're going to loop around here. So that and NTSP is greater than current number. So for example, if this number here was 4, then we wouldn't need to, for example, move 4. We wouldn't need to move these around here because this number is obviously not greater than 4. So there will be numbers in the list, for example, that are already sorted. So to avoid actually sorting and for us to be able to kind of move on to the next point, this kind of just captures the fact that we don't need to move anything and we can move to the next number, for example. So NTSP is greater than the current number, right? So in this case at the moment, NTSP in the first iteration, let's just move that back to 2. So P, if you remember, represented in the first iteration 0 because we've took 1. So I was 1 and then we minus 1, which is 0. So this is 0. So what we're going to do now is get the number in position 0 and we're going to check it against the current number. That's the number that we originally stored. I equals 1, remember? So that was current number represents 3 or stored number 3. So what we're doing first here is 4 is greater than 3 and that's true. So while P is greater than 0, that is true because P represents 0 at the moment, and NTSP is greater than the current number. Now that is also true. Therefore, we're now going to run the swap. So if you remember what happens now is that we're going to swap, we're going to put the 4 into position 1, and then we're going to take the number that's stored in this variable here and put it into position 0. Okay, so what we need to do here then is let's get the number in P plus 1. Now remember P at the moment is equal to 0. So P plus 1 is number 1. Okay, so we get the number that's stored in position 1, which is 3. And that, we don't get the number, sorry, we get the position. So then that should now represent P. So remember P represents on the first iteration 0. So what we do is we get the number from position 0 and we've just basically replaced the number that was in position P plus 1. So the number that's in P plus 1, which is 3, we now replace that with NTSP. P represents 0 at the moment. So we get this number 4 and we replace position 1 with number 4. So what we end up with is this. Okay, so that's where we've moved so far. So now what we need to do is get the variable number, which is 3 at the moment, and put it into position 0. Okay, so let's now go and do exactly that. So what we're going to do first of all is we're going to take P, which represents 0, stored 0 at the moment, and we're going to take away 1 from it. So now it's going to be minus 1. So P at the moment is now storing minus 1. Okay, so obviously at this point, if we try this while loop again, P is greater than or equal to 0. That's not true anymore. That is now false. So this while loop is going to break at this point. And now what we're going to do is we're going to, in NTS, in our list here, in position 0, P plus 1. Now remember, P at the moment, remember that's been changed to minus 1. So now we're going to say P plus 1, which is 0. That's going to equal our current number. That was the original number that we selected in position 1, which is 3. So now what we've done is we've gone ahead and we've taken this number out of this variable and we've now put it here in position 0. So that covers the first iteration of the insertion sort algorithm. So now what we can do, I'll just walk through the second step here. So now this list here, in actual fact, doesn't know, it looks like this. So our list now looks like this after the first iteration. So let's just go through this again in the second iteration. So for I in range, so now this number is moved over to 2 in our second iteration. So I now equals 2. So let's just write this down. I equals 2 at the moment. And then P equals I minus 1. So P now equals on the second iteration equals number 1. Okay, so now we can do this while P is greater than 0. Yep, it is. And NTSP. So we get the number in position 1. So P equals 1. So we're now looking at this number here. And we're looking to make sure if it's greater than the current number. Right, so the current number we stored here, I, which was 2. So position 2, 0, 1, 2. So it's storing 2 here in current number. So we're saying is 4 greater than 2? So is 4 greater than 2? That is true. So now what we're going to do is we're going to replace NTSP, which is 1, plus 1 is 2, equals NTSP. So NTSP is P equals 1, so 0, 1. So it's this number here. And now what we're going to do now is we're going to copy that number over to NTSP plus 1. So P is 1, plus 1 is 2. So 0, 1, 2, position 2 here. We're going to copy across NTSP, this number here. So now they move across. So what's happening now, just going back to here, is we copied P2 down to our variable here. We've checked to see if 4 is greater than 2. And now what we're going to do is we're going to copy 4 over into this position here. Okay, so at this point we've done that. Now what we're doing is we're going to take P, we're going to minus 1 from P. So P now equals 0. Okay, so now we can still loop again because P is still greater or equal to 0 because it is 0. So now what we're going to do is we're going to take P. So P now equals 0. So we're going to take this number here and we're going to check to see if it's greater than our current number, which we originally stored as number 2, remember? So it is. So 3 is greater than 2. So now what we're going to do is NTSP plus 1. So P equals 0 at the moment, plus 1 is 1. So we're talking about this position here, and we're going to copy in there whatever's in NTSP. Now P equals 0. So we're going to take this number here, 3, and we're going to copy it across to P plus 1, which is in this position here. So what happens now is we check to see if 3 is greater than 2. If it is, what happens? We've copied this number here over to position 1. So at this point, we now have looped through again. So we now minus 1 from P. So P now equals minus 1. So therefore, this is not true anymore. So therefore, this loop does not continue. And therefore, we go over to the last statement here. So NTS P plus 1. So that's 0 because P was minus 1. We changed it here. And then we say, put in there the current number. So we get position 0 here and we replace it with whatever's in current number, which was number 2. So that now copies P2 into position 0 and that leaves us with our second iteration. So see if you can go ahead and if you would like to, just follow that through for the third iteration. And if you like to, maybe just change some of these numbers to make it a little bit more interesting. And have a go at trying to follow through this algorithm to see how it works, see if you can follow it through. It is a good practice to try and see if you can follow this through. It can be difficult for new developers or anyone new to programming languages, for loops, while loops. It can be fairly difficult. And that was kind of the idea here, to kind of introduce a topic area, a research topic area, an interesting topic area, but at the same time, just try and build upon your knowledge from the Python Beginners course to help you engaged into some real content, if you like. From a practical standpoint, we're now going to measure the performance of our algorithm. Just taking you back to the first tutorial, bubble sort. This is the code we ended up with. Quickly just explain this again. So here we have a function which is going to take in the algorithm, the data. It's going to measure the performance, how long it took the algorithm to actually sort the data that we pass in. And then it's just going to return how long it took. You can play around with the number of samples and how many times you want to repeat that code in each example, so that you can get a better view or better measurement of the performance. And like I said in the previous tutorial, there is a bigger picture here to performance, which we're not going to touch on in these tutorials with bigger notation, etc. So this is just from a practical standpoint, just measuring how long this is going to take when we pass in a larger set of numbers. So we have this function here, which we're going to take in the name and the numbers that we're going to sort. And this is the actual bubble sort algorithm here. And then at the bottom here, what we've done here is we've created some random numbers between 0 and 10,000. And we're going to use that 5,000 times. So we're going to create a list of 5,000 numbers between 0 and 10,000. And then what we're going to do then is we're going to run the sorting algorithm. So we're going to select what algorithm we want to run. At the moment, it's going to be bubble sort. And then the data set. So we're going to pass that into our run sorting function here. And that's going to then test or measure the performance of our algorithm. So if that still doesn't make sense, just head back to the previous tutorial where I explained this in a little bit more detail, step by step. So let's go ahead now and just grab our new algorithm, our insertion sort. So this is what we were working on previously before we started talking about performance. And now what we can do is we can use the name of it here, and we can now use it down here. So instead of bubble sort, we're now going to be utilizing insertion sort algorithm. So just before we do that, so let's just remind ourselves here, we've got 1,000, 0 to 1,000. Those are the number range that we're going to be working with. And then we've got 5,000 numbers. So let's just bring up and let's just run this. Okay, so that took 1.2 seconds. So bubble sort took 1.2 seconds to sort a list of numbers of 5,000 numbers. Okay, so let's go ahead now and just run insertion sort. Do the same thing again. And notice that's going to take roughly half the amount of time. So this is by no means a scientific way maybe of measuring this, because remember, like I said in the first tutorial, how fast this take can be dependent on a number of different items here. In this practical way, it being that it depends on the speed of your computer, what your CPU is currently doing, maybe how much RAM, and so on. So there can be lots of things slowing this down in a practical sense. But what you're going to find in general between the insertion sort and bubble sort is that these two algorithms, they generally do the same number of passes over the data. But however, the bubble sort averages about twice as much work per pass, whereas the insertion sort, particularly where the data is partially sorted, it does mean that the inner loop can stop earlier. Now, as pointed out from a comment from the previous tutorial, the bubble sort, we could have added something to that algorithm to kind of stop the loop at certain points under certain situations. So that would improve the performance of that bubble sort algorithm a little bit further. However, I chose not to do that, and just for us to really kind of just to showcase from an initial point of view, these two algorithms or sorting algorithms, the fact that we've now found out that although we achieve the same outcome simply by just changing the code in a very simplistic way, we can improve the performance of our code. And ultimately, that can mean, from a practical point of view, that can mean we need less resources to actually achieve the same outcomes. And that's pretty important once we start scaling our systems and our software up. Once we've got hundreds of thousands of people using the same piece of software, that can convert into quite a lot of money saved. So this simple experiment, if you like, just highlights the importance of understanding the code in a way that helps you deliver your piece of software to perform the same actions but utilizing less resources potentially. And ultimately, that's going to be a big cost saving. So I do hope that gives you a good entry point, a good starting point to explore insertion sort a little bit further. So I do apologize if we didn't go into the depth you were maybe looking for. Like I said, hopefully this was a good starting point. And the idea here is in this Python Beginners Plus course is to kind of not move across to or not go into too much depth other than what we've already been taught in the Python beginner course. We're just trying to build upon our knowledge, and maybe for some that might be a little bit slower than they would have anticipated or liked. It's always difficult to try and pace things out for different expectations. So I do apologize for that again, but hopefully there was something here that you've taken and it was useful. And as per normal, I hope to see you in the next tutorial. Just finally, a big shout out to everyone who continues to support this channel as a member. This money goes towards me being able to reallocate my time so that I can generate more tutorials.